So, I welcome students. Now we discuss what exactly is inductive effect. Mind you that it is a permanent polarizing effect. It involves partial charge separation. It transmits across carbon chain through sigma bonded electron. Displacement. These are three important ideas related to inductive effect. Okay, now we examine. According to IUPAC says, IUPAC, transmission effect of charge on chain of atoms via electrostatic induction is called inductive effect. This is very important. It involves transmission of charge across a carbon chain, because we are focusing on organic chemistry, via electrostatic induction. Always it is decided with respect to hydrogen. Notice the reference atom to decide whether somebody can take away the electrons from carbon chain or somebody can flow electron cloud into carbon chain is decided with respect to hydrogen. Hydrogen is the reference element. The other more plausible definition, displacement of sigma electrons from less to more electronegative atom when compared with hydrogen is called inductive effect. More electronegative groups naturally decrease the electron density in carbon chain. Because they withdraw the electron density to some extent, they are called minus I groups. Naturally, metals and other less electronegative groups, when they are bonded to carbon atoms, they increase the electron density in carbon chain and they have electron increasing inductive effect, that is plus I inductive effect. Suppose if the carbons 1, 2, 3, 4 are linked to X, first carbon is linked to X. If X is more electron withdrawing, more electronegative than hydrogen, then the electrons will flow in this direction, making this minus delta. Notice it is not complete minus, it is partial negative charge. It is plus delta. Because this got plus charge, it tries to pull the electron cloud from the neighboring carbon, making it a little again plus delta delta. The transmission of this charge across the carbon chain is significant up to third carbon. It is negligible beyond third carbon. Similarly, there is an electron releasing group like a metal, magnesium, like lithium, like sodium, or like methyl group. They have a tendency to release electrons, and therefore this fellow which is losing electrons on a relative scale gets plus delta, carbon gets minus delta, and this is minus delta delta, minus delta delta delta. This is non-significant beyond 3. A typical order of the plus I groups which are releasing electrons is something like anything that has minus charge can release electrons into carbon chain. Tertiary alkyl group is greater than, secondary alkyl is greater than, alkyl is greater than methyl. These are all electron releasing groups. And electron withdrawing groups, again you can have a long list. These are all electron withdrawing groups. Anything that carry positive charge will positively withdraw electrons. NF3 is greater than, NR3 is greater than, NO2, CN, SO3H, CH4, CO, COH, COCl, CONH2. Then of course you have more electronegative, Cl, Bri, OH, OR, NH2. NH2 is really very weakly electron withdrawing. Phenyl, and of course with respect to hydrogen. Any standard book will contain this much information about inductive effect, which we quickly scan. Very quickly we scan this. This inductive effect is just like shifting a shared pair of electrons in polar covalent molecules. Shared pair is more shifted towards the more electronegative atom. Less electronegative atom acquires slight positive charge. And if you look at CH3Cl, the Cl is getting minus delta and CH3 is getting plus charge. Mind you, it is a permanent effect and propagates through carbon chain. And if you carefully look at this chloroethane, This is significant on first carbon and less significant on second carbon. So it dies away beyond 3, that's what. And this is the order given in a standard book with respect to electron withdrawing inductive effect. Students should learn this really. And this is the order with respect to plus I effect. Students should learn this. It has many applications. In the presence of groups showing plus I effect increase the stability of carbocation. This is very important. Strength of acids increases with attachment of a group that shows that withdraws electrons. How we see in the next video. Presence of plus I showing groups increase the basic strength, because again why we will see in the next video. Reactivity of carbonyl compounds is increased by minus I showing groups. Reactivity of alkyl halides towards SN1 is increased by plus I groups. All this we see in the next video in detail. At the moment we see that inductive effect is an effect where there is a partial charge separation. Charge separation always increases the reactivity of molecules. Thank you very much.